To perform the calcium titrations, you want to begin by preparing your burette with the EDTA titrant and record your starting volume. Make sure you know the initial volume and that you have a burette with no air bubbles in the tip. For the primary standard, you want to begin by performing a trial titration. The purpose of the trial titrations is twofold. First, you want to find out the volume of 2 molar sodium hydroxide that's going to be necessary to adjust the pH. That way, for each sample that you do, since you're always going to be titrating the same aliquot size each time, you won't have to go to the pH meter for every run. You'll get a predetermined volume of sodium hydroxide. You also want to determine the volume of EDTA that's necessary to pre-complex most of the calcium prior to making pH adjustments so that you don't have fading endpoint errors. So you want to begin your trial titration by using your calibrated 20 milliliter volumetric pipette to deliver an exact 20 milliliter sample into your titration flask. Make sure before you remove any solution from the flask that you have a homogeneously mixed solution, even if you mixed this previously. So mix the solution well. Use your calibrated pipette to deliver that 20 milliliter aliquot size, and it's okay to pipette directly out of your volumetric flask. Okay, remember you're going to allow it to go purposely above the mark of the calibration line in the pipette to give you enough time to remove the bulb, slightly releasing pressure until the meniscus is exactly on that mark. Before doing that, make sure that all the extra liquid on the outside has been removed, and as this drains out to the line, that you don't have any air bubbles in the tip. Okay, I have air bubbles here, so I'll re-drain it again. Get rid of the extra droplets. Very carefully drain that meniscus to the mark, and now transfer that solution to your container. Aliquot in the flask, then add approximately 30 milliliters of deionized water. This serves to just increase the volume in the flask to make it easier to see the colors. Next, using a calibrated pH meter, you're going to place the electrode into your calcium solution in the Erlenmeyer flask, and you're going to add 2 molar sodium hydroxide until the pH reaches between 12.5 and 13. You want to keep track of the volume of sodium hydroxide that's necessary to adjust the pH to that level, and then that will become the predetermined amount that you'll add to your regular samples that you'll titrate. Okay, at this point I have a pH of over 12.5. 12.5 to 13 is ideal, and I used right about, let's see, right around 3 milliliters of 2 molar sodium hydroxide. So I will record this volume in my notebook, and 3 milliliters of sodium hydroxide is the predetermined amount that I'll add to each one of my samples. Okay, after which, before titrating this mixture now to determine the predetermined amount of EDTA, be sure that you rinse the electrode very thoroughly and collect those washings into the Erlenmeyer flask. Next, you want to add 2/10 of a gram approximately of the hydroxynaphthol blue indicator. This comes in solid form. You'll add that to your titration flask. Swirl briefly to get all of that to dissolve in solution. And now you're going to titrate with the EDTA until you reach a pure blue color. No traces of red. So this kind of has a reddish violet tint initially, and you're going to proceed through several shades of blue changes, violet color change, through a blue-violet phase, and then ultimately the pure blue. Kind of takes on of a crystally clear shade of blue. Okay. Okay, now this may appear blue, but just to ensure that that's the correct color, you want to record the total volume that you're at and add another drop or two beyond that. And if the shade of blue continues to change, you need to keep going until it doesn't change any further. So this next drop. The shade of blue is not changing any further, so I would record the total volume. The final EDTA volume for the trial titration in this case was 37.18 milliliters. That volume would be recorded, and you want to multiply that volume times 2/3, and that gives you 24.78 milliliters.